Okay, welcome back to the last two examples of systems, the application problems. Okay, so we ended up talking about complementary and supplementary, and now we're going to do the supplementary problem. So it's saying two angles are supplementary, meaning to say that if you add the two angles together, that's going to equal 180 degrees. Then it says the measure of the larger angle is. So if I say that that's x and is means equals, so then I have a less than, so I know I need to switch whatever's in front and whatever's in back around. 12 degrees less than 5 times the measure of the smaller angle. So that means that x is going to equal 5 times the measure of y minus 12 degrees. So now I have defined what x is, and I have another x in my main equation. Therefore, I'm going to replace this x up here with the expression I've defined x to be. So I'm going to have 5y plus y is equal to 180. There we go. So I'm going to combine what I had, like terms. I'm going to add 12 to both sides. And then I'm going to divide by 6. So y is equal to 32 degrees. Then I'm going to plug 32 in to what I know y is. And I'm just going to do it over here just so it doesn't look super sloppy. So I have x is equal to 5 times 32 minus 12. So x is going to end up equaling 85. So I know what x is, and now I know what y is. And I've already done this, so I have added them together. I'm sorry, not 35, I didn't even copy down the right thing. I have them all done, and I copied down the wrong thing. 148, my apologies. Okay. So I already added these together, and they do actually equal to be 180, okay? And I did go ahead and calculate, plugged in the 32, and I did end up getting 148. So that would be example 2 of complementary and supplementary angles for systems of equations. Last one. We have that Randall has 125 feet of fencing to enclose a rectangular part of his yard adjacent to his house. He only needs to fence around 3 sides. So if I know that I have a rectangular yard and this is his house, so he doesn't need a fence here, but he does need a fence on the other 3 surrounding parts of the yard. Okay, so I'm going to go ahead and call this x and this side x, and then this is going to be my y side, the longer side. So I need to split the 125 feet of fencing into 2 x's plus 1 y side. So that's going to end up being my very, very first equation. The second equation is going to be he wants the length of the fenced yard parallel to the house of the wall to be 5 feet more than 4 times the width, okay? So we are going to end up having the y is the parallel side to the house. So y is equal to 4 times the width, which is x, plus 5. So now I have defined what y is. I know what y is here, so I'm going to plug in my expression in for y. So I'm going to have 2x plus 4x plus 5 is equal to 125. Combine my like terms. I'm going to subtract 5 and divide both sides by 6. So x is equal to 20. So this is going to be the width. Now, I'm going to plug in the 20 in for my x over here. So I have y is equal to 4 times 20 plus 5. So y is going to end up equaling 85. And that's going to be the length of the yard. And we did it. We just solved the 6th example of what you could potentially see. All right. So I will see you in the next video, where we're going to be talking about a completely different topic. We're done with the series of systems. All right. See you next time.